Today we're going to do an introduction to R and RStudio that was originally written by my student Mikaela DeRousseau. And in this tutorial, it's assumed that you already have a copy of R and RStudio on your computer. I'll provide a link to the code that we're going to be working through with some modifications, but it's a good template for what I'm working on. And we're going to go through a first session of R. So we're going to read data and determine sizes of data frames and matrices. We'll switch back and forth between data frames and matrices. We'll talk about how to calculate basic statistics, including the use of external packages, so how you install them and then use them. And then we'll finish up with some basic plots from data that we've imported. So this is what the RStudio environment looks like. You can input live commands in this console window, and then you'll see other things populate in these other windows as we go along. So remember that the RStudio is how you interact with R, but you have to actually have R installed as well. So that's why there's that two-step process. Anytime we're starting with a new language, it's always a good idea to show you how you print a basic hello world. So if I just go and use the print command, I can just say hello world right here. Notice that RStudio does a nice job of actually showing you what the syntax of your commands are as you're going along, and so that can be really useful, especially when you're learning. One of the other things that I'll sort of refer to as we go along is a lot of great documentation on the internet that has simple examples like the ones that we're going to go through in this exercise. To get started, let's just create some data which we can use for our various purposes. And so I'm going to create a variable x1. And typically you use this arrow operator instead of equals in R. One of the things that I know from being familiar with other programming languages is that the syntax can be really kind of wonky in R, in my opinion. And so we'll just kind of show you what it is, and then you'll get a feel for it. But unfortunately, there is not necessarily a standard naming conventions for functions and that kind of thing. You'll see sometimes they're capitalized, sometimes they're not, sometimes they use dots, and sometimes they don't. And so that's just something you kind of have to get used to. So the first function that we're going to use beyond print above is this C, which concatenates numbers together. And you'll also notice that RStudio does a nice job of completing our parentheses when we start typing up parentheses and so forth. And so I'm just going to create a list of variables. And then I'm going to enter. And you'll see now that in the environment tab here, that variable that I've created is now stored inside of there. And you can see it in that window, which is really helpful for you to kind of keep track of the data that you have in your session. And so another way to look at a variable which we use all the time is just basically to type the name of the variable into the console, and then it'll just display. If you're familiar with the consoles in Python and MATLAB, it's the same thing. One thing that is different about R, Python, and MATLAB versus languages like C and Fortran is the fact that data types seem to be created on the fly, and a lot of the times it's a good idea for you to check to see that the data type that you have is the one that you think that you do. And so if I use the command class, and then I pass into it my argument, the variable that I just created, you'll see that it shows you that it is a numeric variable. I can also find the length of this array. And again, RStudio is really helping me where it says that length is this get or set the length of vectors and factors, or any other R object that has length defined on it. And so if I do that, then it will show me that I have 7 entries in this data that I created. You can imagine that just typing in the data is a pretty cumbersome way of accessing information. And so there's a number of different ways to get larger data sets into R. And what we're going to do here is we're actually going to do one, and you can actually use the same URL if you're playing along at home. There's a data file that is stored on my colleague's website, Balaji Rajagopalan, and so we'll just put in the URL here. So I'm going to call this variable rain. It's a data set of rainfall. And so the command is read.table. And then again, RStudio helps us with all of the different commands that you need to put into this particular command. Now, a lot of the times, all of these things are not necessary. In fact, when you look at the documentation, you'll see actually that the default values, if you don't end up putting all those parameters in, those default values are there. So we're only going to populate some of those parameters because the default ones will be fine for everything else. In fact, the only thing that we're going to do right now is we're just going to type in the URL, and everything else we can keep as the default. And so we do that, and then it takes the text file, reads in the information, and you can see the information in the environment tab above. So this creates what's known as a data frame. And a data frame is a really useful thing when you are working with statistical information and information that is really kind of well behaved. So you have a situation where you've got two-dimensional, you have columns, which are different variables, and then the rows have a set of values for each column. Okay, and so we can use the view command to actually look at this in a spreadsheet kind of way. And so when we do that, it actually pops up another window in our RStudio, and now you get to see the variables and their values in the different rows. So because we're used to using data frames like this for the purposes of statistics, and we have different variables that we know their names, we want to manipulate them, it's useful to actually create names for our for those columns. And so we can do that just with that concatenation C command that we had before. And so what I'll do is I'll say names. I want to get or set the names of an object. So in this case, I want to set the names. So names of that variable rain that we have, I'm just going to pass into this a concatenated set of strings. So with one quotation mark, I say that the first column is the year, and then the rest of the columns are just the different months of the year. So this is monthly rainfall information. And one of the things that has happened is that I've started to get a little bit sloppy with my quotes. So just be careful. Sometimes the autocorrect kind of thing can play games with you. So, for example, if I put one quote, then the program actually automatically fills in the other quote. So I'll just kind of work with that and sort of just use my cursor to move along, just so that I don't have to type that second one. All right, and so one of the things that's kind of interesting is that it's not going to automatically update that view that we have above, but if I just call that view command again, I'll be able to see it. And one thing that you may may have noticed is that I was cycling through my commands with the up and down arrow. So that allows you, especially if there's a command that you like to repeat often, you can just use the up arrow to access that list of commands for yourself. And so when I do that, it'll review the data, and then you'll see now that all of the columns are in there, just like actually working with a spreadsheet. Now that we are showing that there's these different variables inside this data set, it's nice to be able to actually call those variables with their name, for the purposes of accessing that information. And we'll use some of these columns later in our statistics and that kind of thing. And so, I can say, for example, that I want to look just at the years. And so I go rain, and then it's a $sign basically to access the variables. And RStudio helps us by showing those variables. So I can go like this. And then now it's just going to show me that first column of information. Another thing that I can do actually is I can store that information into another variable. And so, for example, if I just want to store the years only, I can say that the years are rain $year. And then now that creates an array that I can work with just like anything else. So a lot of the times when you're doing this data analysis and manipulation, it really is about kind of slicing and dicing these different columns and rows from bigger data sets and then manipulating them for whatever you need to do with them. So going back to the main RAIN data set for a second, I can look at the type of the data, the dimensions, and so forth, just like I did with the first array. So I can say that I want to know what the class of RAIN is, and then that is where it tells me that RAIN is a data frame. And then I can look at the dimensions of RAIN, the command dim, and then that will show me that it is 129 rows by 13 columns. And it's 13 columns because it's one column for the years and then one column each for the different months. Now, we've actually covered a lot of ground so far, and one thing that you may be wondering is every time I've shown you a different function, I've just kind of talked to you a little bit about the function and typed it in, and then we've moved on. But how do you learn more about each one of these functions? Like I said before, the documentation on the internet is really good, and you can also access that documentation right from within our studio here. And so there I just say help. I lost my place there for a second. And so if I want to say I want to know more about this read table function that I mentioned, and I just call this command, RStudio actually puts the help file that you want to see in this tab here in the lower right hand corner. So read.table also has some cousin functions like read.csv, which stands for comma separated values, read.delim, which stands for delimited files, and so forth. And each one of these is a little bit of a different thing. But when you read this documentation, every possible parameter that goes into this function is essentially shown here, and you can see what the default values are. And sometimes it's enough to just kind of, you can use intuition to sort of start to understand what some of these commands do. But you don't need to just rely on that, because the documentation will then list essentially a little bit of a tidbit about each one of these different parameters that goes into this. And so you can see, for example, the first argument is file, and then it explains, some different nuances about the file, including the path. We'll talk about that a little bit later. And what you could use a URL, as you saw. And so there's different ways to handle that. And then there are logical arguments, true or false, depending on, say, whether there's a header, the field separator, and so forth. So, basically every time you use a new function, it's a good idea to just glance over this. The other thing is that there are nice usage examples, which are normally appear. So just like we're doing here together, you can actually run these usage examples for yourself. And a lot of the times they're self-contained. You don't need anything else. And you can basically go in and try things out for yourself. So that's how you access help. And then another thing that I do a lot of the times is I will just go in and look at so our documentation.org has an HTML version of this documentation with hyperlinks and that kind of thing. You can even run it in a browser, which is really cool. So you don't even need to have your RStudio up and running. You can just play around with things in your browser itself. So, and that's one of the things, not to be too philosophical for a second, but, everybody that runs the software and does this programming language often has a browser in the background with 28 tabs open, looking at the documentation for all these different functions. It's not something that you outgrow. It's not something to be embarrassed about. And that's kind of how you get better, is just by trying to absorb the information and doing a little bit at a time. So another data type that you may come across is the matrix data type. And a lot of the times especially when you're getting started, it's a good idea if you're going to create new variables. You can name the variables in a very descriptive way. So what I'm going to do is I'm going to create a new variable just to play around with that is going to be called rain_matrix. And that just tells me there's nothing special about that name. That name is just a name. It could be anything. I could call it whatever I wanted to, but creating the name in that way helps me as the programmer remember what it is that I'm doing, so that later on I can say, well, why did I name that way? And well, it must be the information from rain stored in matrix form. And so to convert rain into a different type, we just use this command as matrix. But notice actually that you can see that this as, there's all sorts of different versions of as. These functions are used to convert one data type into another. Sometimes that's useful because these commands will require one type of data or another to be input into them. And so it's a nice thing to be able to convert what you have, if you need to. We don't really need to do this right now. It's just for illustration purposes. And so I'm just going to say then that I want to express the data frame rain as a matrix, and then I put that in, and it saves. And notice that RStudio is actually giving you a hint that it is different than the data, the data frame that you have. It's displayed differently, up here. So one issue, though, is that different data types have different syntax for actually accessing them. So if I was to go and say that I want to access the years, and notice actually that one thing to notice is that RStudio, which is usually so helpful, is giving you the silent treatment. And so that it's just like, what are you doing? And it's going to give you an error, which is that the $ operator is invalid for that particular type. If you're working with matrices, you have to index them differently. And so what you can do is basically use these bracket commands, and then the bracket is the rows in the first dimension and the columns in the second dimension. And so again, what I can do is I can say, for example, if I want to take the second row of my data is the values for 1872. So if I wanted to say the rain, and again, nothing special about this variable name, but it's just something for myself to keep myself straight. The rain in 1872, I say that I want to access the rain matrix, and I want the second row and then all of the columns. And so I just leave the second part of that blank. And then when I have that, I end up having just that whole row. Now, for the purposes of what we're doing, I mean, it may be helpful to actually not have that first value in there because, most of the time in practice, you would be wanting to store the second, starting at the second item, right? If you really just wanted to store the rain values. What I did was I basically just gave it a range for what to store. So I said I want the whole second row, and then I want the second column through the 12th column. And then now that that data set that I have does not include the year anymore. So this is really nice because, again, what you can do is you can say that you have that you're taking a slice essentially of a particular data frame, storing it in another variable, for the purposes of working with it further. Earlier, we took information from the internet, and there could also be, in most cases, you will likely want to have all of your files locally on some directory on your computer instead of just pulling stuff off of the internet. And so what we want to show you now is essentially how to kind of navigate the file system in order for you to pull stuff off of different places in your computer. Now, if you look up here in the console window, you'll see that I am currently in the G drive, and I have a folder for my class and, a folder for this, this introduction that we're working on. But in general, if you just want to, and sometimes you might need to have that working directory as a variable or something, and so there's a command for that. There's always a command for that, right? It is get wd. And what that does is it just displays the current working directory that you want to be in. And so if you want to change the working directory, then you can just say set working directory, and then I can say that I want my working directory to be my C drive, for example. And then to check whether that actually worked, I just go back to get wd again, and you'll see that it is changed. Okay, get and set are programming terms that are often used in object-oriented programming. A lot of the times, the user doesn't just have willy-nilly control over all variables, but instead the programmers want to make sure that they control what it is that you're allowed to change and what you're not allowed to change. And so to get something is to access something from a class or from an object, and then to set it is to basically change it. And so you'll see those kinds of things a lot, get and set. A lot of the times, if there is a get, there is also a set somewhere. That they usually come in pairs. Another thing that is kind of useful for you is, now if you look over here, you'll see that that the Files tab shows you the files that are in the working directory that you're in. And so what we'll actually do is we'll actually go back to the working directory that I had before. And it is useful sometimes for you to be able to access file system commands, because maybe you just want to have a list of all the files that you are working with. And so the command dir, okay, allows you to do that. And so in this folder that I'm working in, there's a 2-part R command sheet that we're working from, and then a PowerPoint file. And so it just gives you a chance. And then this actually could be stored in a variable as well if you needed to. So some nice things for the file type, for the file system. And I'm not going to do it here because I don't have a copy of this file in my home directory. But if I wanted to, I could go and read in another data set, and essentially you can now use a relative path if you are in the right directory. So if I had some data, I could just access that without giving it a path, because R knows that I am in my desired working directory. Another thing that is useful, and you're going to see this when you look at the version of the code that I post, is that if I put a so-called hashtag or pound sign in front of something, that is called a comment, and then that will not actually run. So comments are just things that you can put in notes to yourself in a full script. You can put notes all over the place. And so if I run this, nothing's going to happen because it's just a comment. Sometimes you'll hear programmers say that they comment something out if you're working on a script and there's a piece of code that you do not want to that you don't want to actually run. You can put a comment in front of it, and I can actually show you there's a command in here that I don't want to actually run. Like, I'm showing you that this is a command that you can do, but I commented it out because I didn't want that. If somebody were to source this whole file, this would give them an error. So I just put a comment in front of it. And so you can see that, like, a lot of the times when you're editing code and there's something that you want to just turn off, putting a comment sign in front of it is a great way to do that. Okay, so the next thing that we're going to do is we're going to work with one of these variables, and we're going to do some basic statistics. And so I will make use of the fact that I took out that 1 year's worth of data, 1872 data, and I'm going to just do some basic calculations. One of the things to keep in mind is that, especially when we're working with the console, if I go and I say, all right, I want to take the mean of the array that I have, rain 1872. And by the way, you can also autocomplete when RStudio suggests something for you to do just by hitting the enter key. And so when I do that, it's just going to display what the mean is. It's not going to actually store it anywhere. And so if I wanted to store that, I could say, and again, I'm just going to make a variable name. Honestly, like, I would say that it's long variable names to a point aren't a problem. I think that especially when you're getting started, longer variable names are better than shorter variable names. Like, a lot of the times people will start and they will name a variable X or Y or Q or var or something like that. And later on, you won't remember what it is that you did. So being more descriptive is really useful. So I'll just tack on another name into my variable name there. And so now I'm going to store the mean, and I'm just going to run the command again. And now that will actually store it into a variable that I can use later on if I want to. Okay, so we've got mean, we've got median. Okay, and then the variance. Okay, and then the standard deviation, SD. And then the interquartile range is another statistic that you may want. So we just say IQR and then range. And so lots of different things. But a lot of the times, you may not have access to the commands that you want in the base R package. And you will want to use other packages in order to get what you need. There's a really nice package manager that will get you really far, and it's just install.packages will bring it up. And so now you'll see that there is a list on my screen of all these different packages that I can get. Now, I did this earlier today, so I don't need to do it again, but we're going to use a package called E1071 that has some statistical information in it. And it's in this list that you can find here. And so then once you do that, it will basically install the package on your computer. When you install a package, those functions are installed on your computer, but you don't have access to them until you load that package into memory. And so that is kind of like taking out a library book. You use the function library, and then that basically enables you to use those functions, and then you can go ahead and access that. So the skewness command gives you the skew coefficient of the data. That is an introduction on how to calculate basic statistics of an array that you have of data. And so now we're going to finish up the session today with doing some basic plots. And these plots are using what's known as base R. So we're not going to be using a special package for plotting anything. The plots that we're going to make are really basic, but they're going to get you started, and you can kind of go from there. I'm going to be working with different months of this rain data that we have. And so, for example, January, February, March, whatever. So I can go and I can say, I want to know what the distribution of January rainfall was in this place. And so the command to take a look at a histogram is just HIST. And it is histogram of rain in, keep hitting the wrong button, in January. And you can see that the plot is created in the window in the lower right-hand corner of RStudio. You'll see that it is a nice looking plot, but there are some things that we may want to customize. For example, we have a kind of a weird looking title, and then the x-axis isn't really meaningful in this case. And so what we want to do then is we basically just want to call a fancier version of this function. Remember that every time you have a function, you can call essentially the most basic version of that function, or you can kind of add bells and whistles to it. And so I'm just going to use the up key to access the beginning of what I had there. and I'm going to add some stuff. So I can actually customize the number of breaks or the number of bins that I have. And so I can maybe reduce the number of bins just for the purpose of showing you. I can change the X label by XLab. And again, there's a nice little hint of what it does. And I can say January rainfall. And then I can also customize the main title of the plot. And so I can say my first plot, just like that. And then you'll see that it has regenerated the plot and it has reduced the number of breaks. It has changed the X label and it has changed the title. Another thing I can do is a box plot. And then I can do a box plot of one variable. And again, when we have just this one box plot with no other customization, it looks kind of silly. We would like there to be an X label. And actually, what would be really nice, and what I'll use in the demonstration here, is essentially, just to save myself some typing, I'm going to make a box plot of each one of the months of information. And so I'm just separating these calls to the different columns by commas. And so there's going to be 12 arguments there. And then that's going to create a really nice little box plot that basically shows how our data is distributed in each of the different months. Again, I can add arguments to that call that basically modify the labels and the titles and that kind of thing. But just to kind of get you started, there you go. One other thing is that in RStudio, you can actually scroll through the plots that you've already made just with these arrows here. And so that's nice when you're doing a data analysis session, you'll have a bunch of different plots for you to look at. Two more things, actually. We want to make one more plot, and I'm going to show you one more kind of data function, which we will talk about in another session, is you can create random data from a normal distribution. And so random number generators are really useful, especially when doing statistical modeling. And so the command is rnorm. And the arguments are the number of data points that you want to create, and then the mean and the standard deviation, because we know that the normal distribution is fully described by the mean and the standard deviation. I want to just create 10 data points that have a mean of 0 and a standard deviation of 1. And then I'll do the same thing again. Now, one of the things, and you'll actually see this, is that the way that a random number generator works is that unless you give the random number generator a particular random seed, what you'll see is that every time you call this function, it's going to give you different results, hence randomness, right? So if I was to repeat this again, then I would, I would get a different answer. And so again, this is probably the topic for another video, but suffice it to say, this is a way for you to just kind of generate some data to play around with. You can use this random number generator. So now I have two data sets that are the same length, and I want to do a scatter plot between them. Lots of different ways to customize this, but for now what we'll do is we'll make a plot that we want the X information and the Y information. There's nothing special about the fact that we called them X and Y. It's just, what's on the horizontal axis and what's on the vertical axis. There's a command that basically says what point symbol to use, and it's called PCH. And I like just to have spaces between everything just to make it a little bit neater. But I'm just going to pick a different plotting symbol, and you can see that if I run it again with a different plotting symbol, basically it changes the symbol. But that just shows you X versus Y. There's also a line that you can put in, a one-to-one line, AB line, with the commands here. And then the color, you can change the color of the line to make it red. And so then that sometimes is useful when you're doing different kinds of model fit sort of plots to look at how your points go to the one-on-one line. So we talked about a lot, but this should definitely be able to get you started in learning about R and just getting, opening up RStudio and just starting to play around. It's really going to help you, especially for those of you in college or in grad school or what have you. I think a great way to get started with R is just to sort of use it as a calculator. So instead of using a real calculator, you can kind of do some of those basic commands in R, and that'll get you really comfortable when you have to start building larger scripts. But that's it for the moment. Like this video if you liked it, and subscribe to my channel for more.